Okay, this is our last chapter that we're going to be working in. We're going to be in chapter 15. This is the first lesson of May 4 to May 8. You may ask, well, what are we going to do for the rest of the year? Next week will be finals. We'll spend some time at the beginning of the week preparing for that and then running through. We may do some of that this week as well on Monday and Wednesday. But we need to end talking about acids and bases. And so today I want to give you a brief introduction to the whole idea of acid-base chemistry. You're going to need to know this if you go on and take a college chemistry class. So let me say a few things about acids and bases. This is mostly just an introduction for the chapter. We're going to cover 2 more sections. I wish we could do more than that, but we just can't. So when we talk about an acid and a base, most people understand that an acid is something that's somehow dangerous. If you get acid on you, that could be a bad thing. And acids and bases are a particular type of chemical. And I want to give you some basic information about both acids and bases. So let me start with acids. We'll just do it this way, acids and bases. First of all, acids and bases are like flip sides of the same coin. What you're going to find eventually that when you define an acid, you also define a base. It's not going to seem like that right at the very beginning. One of the things I'm going to say, and there's a question on a worksheet that you're going to do, and that is that both acids and bases are dangerous or can be dangerous, and acids and bases can be non-dangerous. We have strong acids, strong bases, weak acids, weak bases. It's a mistake to think, well, this is a base, it's the opposite of an acid, and therefore it is not dangerous. They both can be very dangerous chemicals. Acids have a unique property, and we'll get to the fundamental property here in a minute, but acids and bases are both have something in common. They are both ionic compounds. So they're both ionic compounds, which means they're made up of 2 ions held together, and because of that, acids and bases dissolve in water. They both dissolve in water. And they are both what we would say electrolytes, which means they conduct electricity in water. And the same thing over here. All right? That's the commonalities between them. In fact, I have here a light bulb, and this is an acid, and if I put this in, that light bulb will glow. This is a base, and notice it's a water solution, it's dissolved, and it will glow, and so they conduct electricity. Now, there are some differences. One of the fundamental differences between acids and bases is actually the taste. Acids taste sour. Now you might say, well, then bases will taste sweet, but they don't. Bases taste bitter. Okay, so let's stop and think about that. What things would you know of that would be acids? Well, lemon juice. In fact, any citrus, any fruit which is not ripe would be that. Vinegar is an acid, all right? What tastes bitter? Well, I don't know if any of you had the opportunity to have your mouth washed out with soap, but if you did, it's very bitter. Soaps are bitter. Soaps are bases. And so that would be a fundamental difference between them. But here is the main difference, and that is that when we work with acids and bases, we're actually going to expand this definition, but for today we're going to be talking about something called an Arrhenius acid or base. Mr. Arrhenius was a chemist who lived in Sweden, and Sweden, for whatever reason, the Scandinavian countries did a lot of work with acids and bases, and Mr. Arrhenius discovered something. What seemed to be the key property of an acid is that an acid is a proton, not a proton, well, an H plus donor. And by the way, an H plus is called a proton, an H plus donor. And a base is an OH minus, which is a hydroxide donor. Right? So acids are proton donors, bases are hydroxide donors. By the way, we're going to expand that definition in the very next lesson that I teach you, but that's our first understanding of an acid or a base. Acids give away a proton. I'm going to talk about this for just a second. If I take a hydrogen atom is a proton with an electron. If I take this electron away, so that I no longer have that electron, what's left? Well, this is a proton, but it also, because I had a hydrogen atom and I took away the electron, it's an H with a 1 plus. So these two things mean exactly the same thing. H plus, hydrogen donor, and a proton are the same thing. So one of the things I'm going to ask about when we start talking about acids and bases is whether you can recognize. So let me show you how you recognize an acid. An acid always starts with an H. So HCl, H2SO4, HNO3, HBr, HClO4. Notice what is common, and that is that H is first. And by the way, because these are ionic, if this splits apart, it becomes H plus and Cl minus. H plus, there would be two of them, and SO4 with a 2 minus. H plus and NO3 with a minus. H plus and a Br with a minus. Those would all be Arrhenius acids. With bases, you're going to be looking for a hydroxide. So you could have something like sodium NaOH or CaOH or aluminum hydroxide or barium hydroxide. Notice what you've got here. If it's a base, it's got the OH minus. So this would split apart as Na plus OH minus. Okay? So that's some basic principles of acids and bases. There's one other thing about acids and bases, and I should mention, and that is that acids and bases are known for being able to be we can use indicators with them. An indicator is something which changes color in the presence of an acid or a base. If we were in class, I would have you all have litmus paper. Litmus paper is a little piece of paper, you stick it in the acid. If it's an acid, it turns red. If it's a base, it turns blue. That's litmus paper. Litmus paper was from a plant that grows in Sweden. It's a lichen that they crush up, and it causes, and it reacts. When I first moved to the valley, we had a hydrangea plant in the backyard. If you don't know, hydrangea is a big puffy flower. And ours were bright red. And the neighbor across just right across from us had a blue hydrangea bush. And my wife really liked the blue. And she said, "How could I get a cutting from your plant so that we could start one of my own?" And she said, "Well, it'll be red on your property." I was like, no. It's a blue flower over there. And she goes, "You want blue hydrangeas?" She goes, "You drive nails into the ground. And what's happening when the nails rust, the soil then changes its acidity, and that plant was very sensitive to the acidity of the soil. And depending upon the acidity of the soil would determine what color the flower was. So that flower was an indicator. if you take red cabbage juice and you boil it and then pour different things into the cabbage juice, like lemon juice into the cabbage juice, it'll change colors. But let me show you the one that I'm going to use. And I actually should have goggles, and I realize I don't have them, so you're just going to have to watch this. I have some acid here. This is hydrochloric acid. I'm going to put some of this stuff in. This is called phenolphthalein. And if I pour some base into it, this is sodium hydroxide, you can kind of see that pink start coming out. And then all of a sudden, when we hit a certain point, this whole thing will change pink. That pink is in fact, I may be able to swirl it down. That pink is an indicator that phenolphthalein. Let me get a little bit more of the sodium hydroxide and put that in. See if I can make it turn pink permanently. And there it changes pink. Still not quite yet. By the way, we do a lab at school where we figure out what the molarity of an acid is by doing that. Okay, there we go. That's pretty far over into the pink range. Now, what's interesting is this is now a base solution. We would call it basic. If I pour a little bit more acid in, it's going to change back to clear. You swirl it around a little bit. It'll go back to clear again, because that indicator, that phenolphthalein, is an indicator and tells me that I have either an acid or a base. Now, there's a couple of other things that I want to cover real quick in this video. This is going to be a little bit longer video. I want to talk about naming acids and bases. And I also want to talk about whether an acid or base is strong or weak. An acid which is strong means that, well, we'll get to that in a second. Let's talk about naming. This is actually review from something we did not years ago, at the beginning of the year when we were talking about naming compounds. You may remember we had a thing like this, and we said, what's the first element? And if the first element is a metal, we do one thing. If the first element's a non-metal, but the one in the middle was whether it's a hydrogen. And what we said was we have two types of acids. We have binary acids, and we have what are called tertiary acids. A binary acid means that it's a hydrogen attached to an element, and a tertiary is a hydrogen attached to a polyatomic ion. All right? And those would be our two different types. If it's hydrogen attached to an element, like H attached to Cl, or H attached to Br, or H attached to S, and it doesn't matter if there's more than one here, this gets named hydro. We take the stem of that, chlor, and then we add on to the end of it, IC. So a binary acid, you take hydro, the stem, and end in IC. So this one would be hydrobromic, and this one would be hydrosulfuric acid. And then we would always add acid to it. With the tertiary acids, the way that we named those was we simply took the polyatomic ion and we changed the name of the polyatomic ion. We didn't put a hydro in front of it. Changed the name of the polyatomic ion. So for instance, if we had H2SO4, this SO4 is sulfate, and anything that ended in ATE got changed to IC. So this would become sulfuric acid. If I had HNO3, this is nitrate, so this becomes nitric acid. But if this had been H2SO3, This would be sulfite, and anything that ended in ITE got changed to OUS. So this would have been sulfurous acid. Okay, so that's a quick little review, but you can do that with anything. So let me just show you one. If you had HC2H3O2, this is acetate, and this then would become acidic acid. And by the way, acidic acid is the most common acid you're going to have at home. That would be vinegar. Vinegar is the common acid. So that's that. With bases, we just name them the way that we would have before. So if you have CaOH2, calcium is in group 2. This would be calcium hydroxide. If we had CuOH2, this is copper, but copper has 2 possible charges. Because that's a -1, this would be copper 2 hydroxide. Okay. Now, one last thing in this section, and that is whether an acid or base is strong or weak. This does not mean concentrated or non-concentrated. What a strong acid does is this. It completely dissociates. In other words, if I take, I'll give you a strong acid, HCl, and I put it into water, every one of these will dissociate. In other words, 100% will dissociate. Dissociate means to split apart into the ions. That would be a strong acid. But if I had acidic acid, C2H3O2, the acidic acid, it would split apart into H pluses and those, the acetate ion, but it'll only do that about much less than 100%. I'm just going to throw out about 10%. I think it's even less than that. Okay. Now, I don't have an explanation for you as to why that's going to happen. I'm just telling you there are acids that totally dissociate and some that don't, and the same thing with hydroxides. And so what I want to do is show you what are strong and weak acids. So when we're talking about acids, these acids are strong. HF, HCl, HBr, and HI. And if you look at those, you will recognize that those are all in the 7th column on the periodic table. Fluorine, chlorine, bromine, iodine. The other strong acids are when there are greater than two, I should do it this way. When you have the number of oxygen is, I'm going to do it this way. Take the number of oxygen, subtract the number of hydrogen. If that's greater than or equal to 2, it's a strong acid. So, for instance, H2SO4. 4 minus 2 is 2. 2 is equal to 2. This is a strong acid. But if this had been H2SO3, 3 minus 2 is equal to 1. This is a weak acid. So these ones you memorize, this you'll figure out. Somebody just throw one out. This is HClO4. That's perchloric acid because this is perchlorate. 4 minus 1 is 3. 3 is greater than or equal to 2. This is a strong acid. Whereas HClO, this is bleach, but this is hydrogen, and this is hypochlorite. Hypochlorite, so this would be hypochlorous acid. But because 1 minus 1 is 0, and 0 is not greater than 2, this is a weak acid. When it comes to bases, you just memorize them. Well, you don't even have to memorize them. Anything in column 1 is strong. So that would be potassium or lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and cesium hydroxide. And anything in column 2 past magnesium. So that would be calcium hydroxide and strontium hydroxide and barium. I should have put barium next. It's barium hydroxide and strontium hydroxide. There's 7 strong bases. And you just can memorize those, but it's also, the ones, again, this is column 1 on your periodic table. This is column 2. That's hydrogen. We have lithium, sodium, potassium, rubidium, cesium. And then here we have down here magnesium, calcium, barium, strontium. We don't include magnesium. I've messed up on this, but anyways. So what I have is a worksheet for you, and it's going to ask some questions. It's going to ask you, oh, there's one other thing that I forgot. So this is going to be a little longer video. And that is something interesting happens when you mix together an Arrhenius acid and Arrhenius base. If I take HCl plus NaOH, this is going to become H plus Cl minus Na plus OH minus. The Na and the Cl will go together, and look what else you have, HOH, or we would say H2O. If I had potassium hydroxide plus calcium, say copper, I don't want to do that, plus H2SO3, this would break apart and the potassium would go with the sulfate and the H and the OH would go together, and we would have to balance this. We'd need a 2 here and a 2 here. In other words, when I mixed this together, which was sodium hydroxide and hydrochloric acid, what I got was salt water. Now, this is an acid. This is a base. This is salt. Now, some of you say, well, of course it's salt. It's NaCl. But the reason it's a salt, the definition of salt in chemistry is that a salt, not assault like you're hurting somebody, a salt is what is formed when you mix an Arrhenius acid with an Arrhenius base. By the way, the other product is water. So this is an acid. This is a base. This is my base because it's got the hydroxide. This is an acid. This is a salt, and there's my water. Here, acid, base, salt. So let me just do one other one. Let's say we had vinegar, HC2H3O2, and we mix that with magnesium hydroxide, and that would give us magnesium acetate plus water, and we need a 2 here and a 2 here. This is my acid, this is my base, and this is my salt. And you're going to be asked to do that on the worksheet. So you can read through section 13.1, but 15.1, excuse me, but I've actually covered quite a bit of stuff that isn't in 15.1. I'm sorry this video took so long, but there's just a lot of material here to cover on this first section. So work the worksheet. It covers everything we've covered in here. You may want to kind of watch through this and then to get your worksheet out and watch through it, and you'll be able to do the problems. So.